Hey folks, so today we'll talk about the personal knowledge graph for the artificial intelligence memory and all the challenges that we have with the knowledge graphs when we develop the application. So I already have a couple of articles that describe this graph object impedance. Yeah, so that we have the ontology, we have the graph databases, and then we have the application code. And ontology not always suitable for the graph databases, and ontology is more wider set of logical rules that allow us to construct the graph, but the majority of the property graph databases do not support the ontology, so you always need to lift the ontology validation on the application layer. And another observation of myself, that when you try to map the type that represents somehow the ontology constraints, you also more restrictive with the types, and then we have this graph object impedance, because graphs are more flexible structures than the classical object in object-oriented programming. So I see the objects more as obstacles, and then in the 80s it was the try of do the object-oriented databases where object was the first-class citizen, but somehow they failed because they mimic the class structure of your application. So it means that they make the data not reusable actually. So it was more the extension of the application, and this approach was not survived. But maybe the types actually it's a good answer to other problems with the graphs and ontologies and rules and all of things, because quite often in ontology we have the quite complex hierarchies and quite complex relation of the subclasses that majority of the property graph databases are not able to maintain. And then it's much easier to implement this class hierarchies, subclasses, and all other things in quite polymorphic way. So object-oriented programming allows us to do it, but it's still quite constrained, and probably I find the answer. And one of the answer is this, polymorphic databases. Yeah, the polymorphic databases is an interesting concept, but they built on not on top of the objects, but they built on top of the type theory, and they have quite special types. It's not our regular types that we use in our favorite programming languages, but they utilize the concept of the dependent types, where the type could have the dependency on another type and build the complex relation on top of it. And the dependent type theory is the extension of the formal logic actually, so it's much richer and more complex mathematically proved mechanism that allow us to build quite complex relations. And for example, the Typedb support all the things. So Typedb combine two interesting approaches. About the first approach I was talking on my previous article a lot. It's the concept modeling. And in a concept modeling, you have good old entities, you have the relations, and you have the attributes. And it's quite important thing that when we separate the attributes from the entity itself, it's make them much more flexible than the regular objects, because right now you could say that the different entities somehow share the same set of attributes, and in this way you could build a quite powerful polymorphic capabilities. So you could say that if the object have the ownership field, it's have the ownership capability, and you could query in more abstract way everybody who owned by somebody and all other things. So it's open, quite flexible, and quite generalized way of querying the things. And Typedb actually combined the conceptual modeling, where you have the entities, relation, and attributes together with the type theory, because in type theory your entities became the types, your relations became the dependent types, where dependency are the objects, and your attributes became the dependent type also because they owned by type. So they owned by entity. So it's dependent type that target to the values, not to the objects. And yet another quite interesting observation that you have something similar with the concept graphs, because in a concept graph the relation is the entity itself, and in a concept modeling you have the relation that could have the complex dependency to the multiple entities. And in this case, in a Typedb and the dependent type theory, you have the ability to model the hypergraphs. But still in quite constrained way, because you have the type checked constraint schema that you need to describe the configuration of your relation and have the exact match of the entities and all of things. So it means that it's still more limited, but it's flexible enough to describe quite complex domains. And you have a couple of types of the polymorphic relations. So first of all, you have the inheritance, and with inheritance you capable to model the complex hierarchies. Then you have the interface polymorphic dependencies, so you could share the set of attributes that somehow deform the interface and could have the same set of relations and all of things. So it's really powerful for the ontology description. And the last part, but not least, you could have the parametric polymorphism, and with the parametric polymorphism actually you could have the other parameters that actually is something if you develop the maps to the generic types. But it's not the end. Now you control the flexibly the schema, but you still want to have the constraint on the relations and all of things. And you could do quite complex validation rules because Typedb support the deductive database capabilities and rules, and it's super powerful. Somehow the Typedb combined the type theory together with the formal logic constraints, and it's really powerful to describing and reflecting the ontology. But what's more important, that your query became the same. So the language that used to describe the schema of the data actually quite close to the language that describes the queries, because your query actually is the complex type that needs to satisfy some constraints. So it's still line dependency of dependent type theory, and it's extremely powerful and extremely interesting. So maybe we just need more polymorphic databases, but unfortunately the Typedb do not support the ability to run on the user devices yet. We need to experiment in this field. I will let you know what are the result of my experiments, but the polymorphic and type-based databases actually is more suitable for the graphs even than the graph databases itself, and it was my biggest discovery this week. So that's all that I was keen to share with you. Subscribe to our channel, follow me on Medium, and see you next time. Cheers.